Assalamualaikum warahmatullahi wabarakatuh. Hello, my name is Mohamad Azfar. So today, me and my group members will talk about our created MATLAB program that we had choose from mainly from formation evaluation, drilling engineering, reservoir engineering, static and dynamic, fluid mechanics, and so on. So I will start our presentation today by presenting the background of our two problems to create our MATLAB program. So let's start. So firstly, our first problem that we have been applied to our MATLAB script is based on reservoir engineering subject on the chapter saturated oil reservoir. This chapter explains us about what saturated oil reservoir is. The derivation of material balance equations also had been explained in this chapter, such as material balance equation for saturated oil reservoir, Schitt's material balance equation, and materials balance as a straight line by using a method developed by Hafiz, and also a calculation of certain properties such as formation volume factor, FVF, and solution gas oil ratio SDOR from differential evaporation and separator tests. In general, saturated oil reservoir is a condition where oil and gas are in thermodynamic equilibrium. The chemical force exerted by each component in the oil phase is equal to the chemical force exerted by the same component in the gas phase. Thereby, they are eliminating mass transfer of components from one phase to the another. From this chapter, the problem is to solve the initial oil and gas for both free and solution in place by using the Hafiz method. With the given cumulative oil production NP and cumulative gas oil ratio RP as function of average reservoir pressure. So by solving the problem by using Hafiz method, we can obtain a straight line in a plot that can be used to determine the slope and y-intercept that often help us in determining the parameters such as N and M.
Assalamualaikum, my name is Mohamad Hafiz and I am from CGE443. Today I will present you about our predefined script for the problem 1. So on this script we more focus on the data input from the user to let them apply any data for the similar problem. The script is including array, control flow for the data input, and the plotted graph from the calculated data. For the step 1, we use the for and loop as the main loops for the input data from the user. So the first loops is for user to set their limitation, and the second loop is to set the step or the number of looping for their data input. Next, for the step 2, we put the while loop to validate the input data from the user to make sure the value of the data input is only positive. So we put the condition is set data to be in positive only, and the statement will let the user to input the correct data value, as you can see on the script, MATLAB script. There are 6 elements for the user to input, which is the pressure, cumulative oil production, cumulative produced GOR, oil volume factor, solution GOR, and the gas volume factor. The data that obtained from the user will be stored in the array for each elements. The size of the array depends on the number of looping, which is from the variable n or the variable steps. And then at the line 41 is the end of the main loop, which is the end for the for end loops. Okay, the next steps, we display the stored data in array in a table form, which is we use the format short G to make the value more uniformly. Okay, for the next step, we substitute all the stored data in array into the calculation to calculate total formation volume factor in line 63 to 65, calculate the gas expansion term, line 67 to 70, and the last one is in line 72 to 75, as you can see, for the calculation for oil expansion term. For the initial value, we set the function to the position 1, 1, And for the value for all pressure, we only consider it from the second data to the data that been set by limit. Okay, this one we calculate the data for plotting. And for first one, we calculate the y component, which is equal to f over EO, and for the x component is equal to BT initial EG over BG initial EO. And we also set a is-none function for each axis to make sure that the value calculated in integer form, and the is-none function will execute the complex number and the 0 over 0. Okay, for the next step, as you can see, we put the ax function for the size of the graph, and the function of scatter xy is for plotting the data scattered on the graph. And we set the as y and x axis by using the function at 93 and 94. Then we put the label of each axis at line 95 to 96, and we construct the linear line by using the function isLine. And then we use the function graph equal to polyfit xy1 to get the data from the graph. And the data from the graph, we only consider the y-intercept and the gradient of the equation. Then for the final step, which is the final calculation, we display first the data obtained from the graph, which is the y-intercept and the gradient of the line in a linear equation, which is y equal to mx plus c. And we use the formula of g, which is the initial gas in place, to calculate it by using the data obtained from the graph. And at line 107, the calculation for initial gas in place. And that's how you get the solution for this problem.
Assalamualaikum warahmatullahi wabarakatuh. My name is Mohamad Azfar bin Johan, and I will present to you about the output in the command window after the script were executed. So as we can see here, these are the script, and the right side we can see there are a table which is contain the data that we will use in the command window after we run. So we run. So the first output that were executed is how many set of data do you have in the number of rows. As we can see in the right side at the table, there are 7 rows of data with different pressure and different value. So we enter here 7 and then press enter, and then it will ask to key in the data in the first row, which is this. So we put the data for the pressure T33300 and press enter, and the cumulative oil production, which is NP, is 0, and the cumulative produced gas oil ratio, which is RP, 0, enter. Oil volume factor, which is BO, we put 1.2511 and press enter, and the solution gas oil ratio, which is RSO, which is set there 18510. And lastly, the gas volume factor, which is BG, is 0.00087, and then press enter. And then the next output that executed is it will ask to key in the data to, which is the second row in the table. This is so we will put all the data in the row number 2, 3, 4, 5, 6, 7. So press this. So after all the data have been inserted, so we will press enter, and then this will executed. There are a graph, so we will talk about it later. So what will executed, which is a table, it will execute a table of the data which executed all reservoir, which is have 7 row and 6 column about all the data that we have inserted. So we will also get the total formation volume factor for oil pressure, which is BT, which is this, in one row. and then we can get the EG, which is the gas expansion, which is this, and then we will get the EO, which is the oil expansion, which is this, in one row. And then from the collected data, we will calculate for the Y and X component, which is the Y equal to F over EO, which we will obtain this value, and then the X component, which is X equal to BTI multiplied with EG divided by BGI multiplied by EO, will get this. So after we get the X and Y component, we will get the plotted graph. So this is Y axis and this is X axis. So this is the point that we plot, and then we will get a linear equation from the graph, which is Y equal to 58.15x plus 108.70. As we can see here, the C value, which is the Y intercept, is equivalent to the N, which is this Y intercept. So N is the initial oil in place, which is 108.7, which is this Y intercept. And we can see here too, this is the M value, which is the slope of this graph. This graph has a slope of 58.15. And then finally we will get the initial gas for both free and the soft gas, which is G, which is 139066. So that's all from me. Thank you.
Okay. Assalamualaikum warahmatullahi wabarakatuh. My name is Mohamad Azfar from group CGE443 4C. So for my part, I will talk about how to solve dry gas reservoir question by using MATLAB. So a little overview of this problem is this chapter explains about dry gas reservoir, calculation of gas in place by the volumetric methods, calculation of unit recovery from volumetric gas reservoir, calculation of unit recovery from gas reservoir underwater drive, and the material balance equation. So our problem needed us to use calculation of gas in place by the volumetric method. So take a look at the next slide. Our problem is to calculate the gas initially in place volumetrically G, and to plot PZ versus GP in the graph. So we can determine the presence of water encroachment. So in this script there will be an array and a plotted graph command. So we take a look at first step. This is the initial phase to solve this problem by using command as been stated beside me to set up a loop to get the number of set data. If we can see here, there is a limit in the set of data that we use. Then step equal n is the number of looping that present in the question. While loop is needed to validate the input data that given from the question. This has to follow some restriction, which is the set of data input must be positive value. The data will be stored in array for each component, and the data that we put in the script is years, reservoir pressure, Z, and cumulative production. So line 31 is the is stated that is the end of the loop, which is we call end loop. The next step, we will construct a table. So the data that stored in array will display a table that consists of a set of data that identical with the question given. So the value of the data and the unit as data will be same as the question given. So we can refer this as the table 1. So for the next step, we will construct a new table. So by inserting the command beside me, a new data will be created in form of table with exact value and SI unit. MATLAB will automatically calculate a value according to the command that has been set up in the screen section. So the new value or new unit that we get is P over Z. So for the step 4, this is the most crucial part and the hardest part that needed to plug in the script, which is we need to calculate the initial gas volume, which is V. Then for the next step, This is just the part where we state the component of the graph. We build up the component of the graph. So at the line 74, we can find the equation that needed from the before slide to get the V value. And so we can see here that from line 78 to 85, there is a command that refer to the component of the graph such as sine of graph, range of axis, range of y-axis, level of x-axis, level of y-axis, and so on. So for the final step, we will hit the button run, and a graph will be displayed in our Windows screen. So the graph is P over Z against GP. So from the graph, we can find the initial guess in place, which is our objective. So at P over Z equal to 0, we'll give the value of guess initially in place as G equal to GP.
Hi, Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Hariz Kamil and I will run, not me, the MATLAB. I will show you to run the script. So first thing, just type the name of the file. So from this, I just have to key in the data from the question. Okay, first is 5, and what year? The first is 0. The pressure is 1798. The Z is 0.869. The cumulative is 0, and the next data is 0.5. Pressure is 1680. Z is 0.87, and the cumulative is 0.96. So the third one, which is which year 1, the pressure is 1540. The Z is 0.88, and the cumulative is 0.12. So the data for year 1.5, the pressure is 1428, Z is 0.89, and the cumulative production 3.21. And the last one data is under year 2. The pressure is 1335, Z is 0.9, and last one, the cumulative is 3.92. So from the key in data at the input, it will give us the table of the data, so you can easily to read it. So the porosity is 0.13, SWI 0.52, area is 1060 acre, the height is 54, and temperature is 624. So by finishing key in all the data in the input, so it will give us the value of the volume, which is 0.16 in terms of smaller scale. And the next one is the value of the S, which is GP, and the value of the Y, which is P over Z. And the last one is the answer for this problem, which is the gas initially in place, which is the answer is 18.25 mm feet square. So as we can see, the graph is did not reach the x-intercept. This is because the data is too big to reach the 18.25. So because of that, it did not reach the x-axis. Because if we want to get the initially gas in place, the y-axis equal to 0, which means P over Z equal to 0, and we will get the value of the G. So that's all.